Okay, so when we add and subtract rational expressions, we have a number of steps to go through. Okay, so steps. 1, factor all of the denominators completely. Or maybe I should say completely factor all of the denominators. Okay, so our first step is to factor denominators. We're not going to worry about the numerators right now. Okay, so don't worry about the numerators yet. Many of you need practice on factoring, so you're going to have to practice your factoring, right? Because if you can't factor, then the whole thing is all downhill from there, right? So don't worry about numerators yet. Okay, after you have completely factored the denominators, you're going to state the restrictions from the factored form of the denominator. So state restrictions. Okay, so remember, we're not multiplying or dividing. We're going to add or subtract. You don't have to worry about flipping anything, right? All we do is we take the expressions, we factor the denominators completely, and we state the restrictions from the factored form of the denominator. Only the denominator. Okay, not the numerator. Don't care about numerator for restrictions. From the factored form of the denominator. Determine what the lowest common denominator is. So determine the lowest common denominator. Okay, so we're going to factor all the denominators. Then we're going to state our restrictions, right? It's always factor, state. It doesn't matter really what we're doing, right? It's always factor, then state restrictions. Okay? Whether you're multiplying and dividing or adding and subtracting. Determine the lowest common denominator. Express the rational expressions as equivalent rational expressions. So express the rational expressions. So you're probably only going to be adding or subtracting 2 things, right? But I mean, this could be 3 or more. But in general, we're going to stick with 2. So you're adding 1 term, 2 terms. Okay? So express the rational expressions. So, usually 2 of them, right? The rational expressions as equivalent rational expressions. So this goes back to day 1, equivalent rational expressions. With a common denominator. So it's like fractions, right? You can only add or subtract fractions, rational expressions, choose your word, that have a common denominator. Okay, with a common denominator. Add or subtract the numerators. Okay, leaving the common denominator, right? We don't we don't change the denominator, right? Once we found a common denominator, like fractions, you change everything to be over 7, then you add, it's over 7, right? It's not over 14 because you added, or over 0 because you subtracted. So add or subtract the numerators, but keep the denominators the same. But keep the, let's call it LCD, right? For lowest common denominator, because that's what you're going to have. You're going to have 2 rational expressions that have this lowest common denominator. You're going to add or subtract the numerators, but keep the lowest common denominator. You're going to collect like terms in the numerator. Like terms in the numerator. and express as a single rational expression, right? So that's the whole idea, is we just get a single expression out of this and express as a single rational expression. And then simplify if possible. Okay, so if we factor denominators, right? I mean, if you just did that on any rational you ever saw, that's always a good first step, right? It doesn't matter if you're multiplying, dividing, adding, subtracting. Factor the denominators. From the factored form, state the restrictions, okay? Or keep them in mind. Remember yesterday we only had to state restrictions on one of the questions. Determine the lowest common denominator. Express the rational expressions as equivalent ones, right? So maybe we have to multiply by 2 over 2 so that we get this lowest common denominator. Then we can add or subtract the numerators, but keep the lowest common denominator. Simplify the numerator, right? Because that's what you're doing, adding or subtracting. And then simplify if possible, which means maybe you can factor the numerator. Maybe you end up with 4x plus 8, and you can factor that. And then that factor will actually cancel with something in the bottom, right? Maybe there's an x plus 2 in the bottom. So that's step 7, to simplify if possible. If it's not possible, if you look at it and say that doesn't factor, then you're done. Okay? But if it's possible, then you want to further simplify. Okay, I'd ask if there are any questions, but we haven't done anything yet, so let's do something. Let's just take a look, just, adding fractions, right? So to add, subtract, you must have a common denominator. So again, if you're coming out of 20-1 and you know how to add, subtract, by all means do it by whatever method you like, okay? So example, let's say we got 3/5 plus 1/2, okay? Equals 3 plus 1 over 5 plus 2 equals 4 over 7. That's not how we add fractions, right? We don't add the numerators and then add the denominators. Okay, you can write it down and then just put a big X through it saying, don't do this. Okay, what do we do? Okay, now since they're fractions, we don't have to factor anything, right? So what is the lowest common denominator for 5 and 2? 10. So what we're going to do is now change these to equivalent by multiplying the 3 over 5 by 2 over 2. And multiplying this by 5 over 5. Right? Remember, when we do equivalent, we're multiplying by, what's 2 over 2? 1. Right? So we're not changing any value, we're just changing the form. So this becomes 6 over 10, and this becomes 5 over 10, and we get 11 over 10, right? Which is the correct answer for that. Okay, so that's what we do with fractions, right? You've been doing this since, I don't know, middle school, I'm guessing. Maybe pre-middle school. Maybe you did this in grade 4. I don't know. Okay, so let's try some monomial rational expressions. Simplify. These are monomial. State restrictions. Okay, so the instruction here is simplify, right? Tomorrow the instruction will become solve, because we'll be solving rational equations. Right? Solve means to find a value for. Like, what's x that makes this true? We're not going to have anything that makes this true, right? Because in order for that, you have to have an equal sign. And we don't have anything, there's no equal. So if you don't see an equal sign, you cannot find a value for x, right? So all you can do is simplify the expression. Okay, we're going to simplify a. 3 over 5x squared plus 1 over 2x. And you may say, hey, that looks a lot like the one you did, 3/5 plus a half, but this has variables in it, right? That's the only difference. So when we do a lowest common denominator, we have to actually do two, right? We need two things. We need the number and we need the power of x. So what number? 5 and 2. 10. X squared and x? X squared, right? We're going to go for the higher value, right? That's what's going to be common to both. So I need to turn these denominators into 10x squared, right? Each of them has to be 10x squared. So what are we going to do with the 3 over 5x squared? Yeah, times by 2 over 2, right? To give me 10x squared. What are we going to do with the 1 over 2x?
5x.
Okay, multiplied by 5x over 5x. So remember, you're always multiplying by 1, just in a different form, right? 2 over 2, 5x over 5x. So this gives me 6 over 10x squared. Oh wait, non-permissible value. There was nothing to, what's the restriction? X can't equal 0, right? The usual boring monomial restriction, right? Monomial restrictions are always just the variable can't be 0, right? Because there's no plus or minus down there, right? It's binomials that get a little more exciting, right? And factored binomials. Okay, plus 5x over 10x squared. Okay, so the denominator is common. It's 10x squared. And what's the numerator? Who thinks it might be 11x? You'd be wrong, unfortunately. It's 6 plus 5x. Because they're not like terms, right? We got a number and we got, is this on the quiz? What?
Was it?
No, this was not on the quiz. You got to make all kinds of different mistakes on the quiz. But it had nothing to do with this. Okay, so final form, 6 plus 5x, right? They're not like terms. Got a 6, got a 5x, you cannot add them and get 11x. You can try. Many of you did yesterday. You tried to do this. It doesn't really work, so. And remember, look, quizzes are feedback, okay? Good or bad, right? So whether you scored 22 out of 22 or 2 out of 22, it's just feedback, right? It just tells you, I should have done a little bit of work, or hey, I'm right on track here. This is good. Yeah, I see I made a simple mistake, or I made a couple of mistakes. No big deal. Just be a little more careful next time. Or I really need to review factoring binomials because I lost a lot of marks because I didn't factor the binomials properly, right? Or I've got to start to recognize difference of squares, okay? Because a lot of people, you didn't factor the x squared minus 9, right? You didn't factor this as a difference of squares, there go a whole pile of marks. Don't want to say that too loud because they're out there writing. Okay, so that's it. 6 plus 5x over 10x squared. B, 1 over 4x minus 3 over 8x squared. Okay, what number do we want on the bottom?
16x squared.
No, too big.
Oh, yeah, 8.
Okay, 8, yeah. So the lowest common multiple, we're looking for the lowest common multiple of 4 and 8, which is 8. Okay, now, if you did go higher than you needed to, right? Like if you went with 32x cubed or something, what you would find at the end is you would be able to simplify that out, right? In other words, your top would factor and be able to simplify. Okay, we should hit some of those, so I'm not going to artificially do that here. Okay, so we need 30. So what are we going to do with the 1 over 4x?
2x.
Okay, 2x, 2x. What are we going to do with with this one?
Nothing.
We don't need to change it, right? It already has the lowest common denominator, 8x squared. Okay. So if you really want to show something, you could go times 1 over 1, but you know. Okay, what do we end up with? 2x over 8x squared. So remember, these are equivalent rational expressions, right? This goes back to 4.1. Minus 3 over 8x squared Okay, and then we get to combine that, 2x minus 3, and keep the common denominator.
Just try to sneak in and out, you got me.
It's okay. It's for a good cause. What's it for? Basketball. That's a great cause. That's not even a good cause. 2x minus, questions? Comments? Concerns? No? All good? Next. 4 over 12x squared plus 3 over 5x. I do this one slightly different. If it confuses you, say, that confuses me. All right? And then I'll go back and show you another way. But this is the way that I normally kind of show this. What's the lowest common denominator? So what's the multiple number? Let's go with 60. Okay. 5 times 12, right? 5 is prime, 12 doesn't include a factor of 5, so you just have to multiply the two together. So 60. And variable-wise, what are we going to have? X squared, right? Okay, so we know the lowest common denominator is 60x squared, right? So I'm just putting down a big fraction bar, and I'm putting 60x squared on the bottom. Okay. Now, let's start with the 4. What does the 4 have to be multiplied by to make this, or what did you do to this to make it 60x squared?
5.
So what do I have to do with the 4?
5.
Multiply it by 5, right? And what did I do to the 5x to get 60x squared? Multiplied by 12x. Okay? So what I've removed a step, right? So that's it. Instead of showing this as, it's sort of equivalent to this, right? It's 4 over 12x squared times 5 over 5 plus 3 over 5x times 12x over 12x. Okay? So does what I did make sense? Okay, you're looking at it, you can say, okay, I see what you did, and do you think it's better? Okay? Yeah, I mean, it takes something out, right? We're still doing the exact same stuff. Okay, what do we got? 20 plus 36x over 60x squared. Right? Yeah, and they're all even, so we can divide, we can simplify this, right? Okay, but I want you good? This is good? Yeah, okay. So if I'm confusing you, let me know, right? So then I'll go back or do a different way. Okay, is there a number that goes into 20 and 36 and 60? 2 does. What else? If 2 goes in, you could always try 4. Does 4 go in? Okay. If 4 goes in, you could always try 8, which doesn't, right? Okay. So, here's what we can do. We can divide everything by 4. So, let me show you what it looks like, and then I'll show you why I did what I did. So, divide everything by 4. That's what I end up with, right? Now I'm going to show you the justification for doing that, okay, just in case you're... So what I would do is go over here, factor a 4 out, and factor a 4 out of this, like that, and then cross off the 4, right? Yep.
Couldn't you just simplify the 4 divided by 12x squared first and save yourself some time?
Could have. I would look in. So the question was, can you just simplify the 4? Yeah, because 4 over 12x squared would be 1 over 3x squared. So we could have done that. Okay, then we would have chosen 15x squared as our lowest common denominator and ended up at the bottom without having to simplify. Right? But then that would have, so I just went and said 16x last one. No. But then that would have meant that I couldn't show you the further simplification, which wasn't part of this. He says trying to recover. Yeah. Okay, so is this all good? Okay, so let's try the next few like this. 9 over 8x plus 3. Okay, this is what it looks like on paper, right? 9 over 8x plus 3. this is how I'm going to write it. 9 over 8x plus 3 over 1. Okay, because if I'm adding or subtracting rational expressions, oh, and we never stated the number, they're all x can't be 0, okay? Let me go back, though. I did it on that one. Okay. What's the lowest common denominator? 8x. So let's just write it down here. What do I do to the 9 to make it over 8x? Don't have to do anything, right? It already is. What do I do to the 3? That's what it is. You're getting slightly ahead. We're going to multiply it by 8x, right? So since the 3 is over 1, it's got to be multiplied by 8x over 8x, but we already made this, so we're only going to worry about the numerator. Okay, we get 9 plus 24x. Okay, anything simplify? Can I just cross those x's off? No. I mean, you can, but you'll lose marks. Okay? You can't. They're not, it's not a factor, right? A factor needs to be something written in front of a set of brackets, like I did back here, right? That's the justification. See, I factored out a 4, and those cross off. Simple way is just to say, hey, they're all divisible by 4. I'm just going to divide them all by 4. Okay? But it's got to be all 3. Can't be 2 out of 3. Okay. 2p plus 5 over 6p squared. Okay, now we're getting into minus 3 over 10p. Okay, so p can't be 0, right? Since the denominator is only monomials, there's nothing to factor, right? So we're not factoring. Okay, you want to do this the same way as the other ones? We'll write the common, we'll just put a big fraction bar down and write the common denominator. Okay, 6 and 10, what's the lowest multiple? 30, right? 30. P squared and p. P squared. You didn't say p cubed, did you? And it came out with a yawn. Okay, it's p squared, right? We only need to go with the highest power of p. We don't need to combine them. Okay, I have 2p plus 5. It's a binomial, so always write binomials in brackets. Okay? Even in the original question, this was the original, it doesn't hurt to do that. Just to remind you, this is a binomial. I'm going to encase it in brackets, which are actually parentheses because brackets are square, but you know, I'll call them brackets. Okay, what do we need to do to the 2p plus 5? We got to times it by 5, right? To get 30p squared, we multiply by 5. Okay, minus, because that's what's there. And what do we do with the 3 to get 30p squared? Times it by 3p. Okay. Everybody good with this method? Right? This is a heck of a lot easier, I think, right? Because it just saves you. You won't see it in the book. I'm pretty sure they'll show you the first method I showed, right? But I kind of like this. It's a little neater. Okay. Now, the 5 has to multiply 2p plus 5, right? Which will give me 10p plus what? 25 minus 9p. All over, bless you. Okay, does this simplify? P plus 25. Right, and remember, the denominator is never going to change once we get here unless there's a common factor and we get to simplify at the end. So the denominator won't change until the end, and if there's a common factor we can simplify, then it'll change. All good? Okay, one more of this, then we'll go to binomial denominators. X minus 4 over 24x. Okay, x minus 4 over 24x plus 5/6. Okay, and x can't be 0, right? Monomial denominator, just the variable can't be 0. Okay, what is our common denominator?
24x.
24x, right? Okay, 6 and 24. 6 goes into 24. Okay, what do I do with the, and remember, I'm going to enclose this because it's a binomial. I'm going to enclose it in what I'm going to call brackets, but are parentheses. What do I do to the x minus 4 to get it over 24x? Nothing, it already is, right? What do I do with the 5? Okay, now we can remove that, expand this. Okay, so since there was nothing to do, now the reason I want this in parentheses is if I do have to multiply it by something, I need to remember the distributive law, right? That it's got to multiply everything in the brackets. Okay, and ultimately what do we get?
21x minus 4.
Okay? All good? Just smile and nod. What? Are you okay with that? X plus 20x. Remember, no number written in front is 1. So 1x plus 21 plus 20x gives me 21x minus 1. Okay? All right, let's move on to binomial denominators. Instructions again are simplify. They won't change until tomorrow, right? When then they'll become solved. So simplify. This is going to have binomial denominators. And state restrictions. Okay? I mean, you might be added. Why are we stating restrictions? We're never doing it. Tomorrow when we solve, we will do something with the restrictions. Okay? So that's why we're just practicing stating restrictions. 3 over x plus 2 plus 5 over x plus 4. Okay, is there anything to factor? Because that's step 1, right? Factor.
Left side.
What would you factor? There's nothing, right? It's just x.
Oh, no, maybe state restrictions, and then we...
Okay, so we factor. No, there's nothing to factor. State restrictions. What can't x be?
Minus 2 and minus 4.
Minus 2 and minus 4. Okay? So, what is our common denominator going to be? I'm going to go back, and I'm going to do this old school way, and then the next one we'll do new school way, and you could choose which way, and again. So what's our common denominator? Nope. So you need one of these, and you need one of these. So our common denominator is this times this, right? Because if x were 12, then this would be a 14, this would be a 16, right? And your common denominator would be, okay, bad example. If x were 7, then you get a 9 and an 11, and your common denominator would be 9 times 11, right? So you have to multiply them together. Okay, so our common denominator means that I'm going to multiply this by x plus 4 over x plus 4. And I'm going to include, right, just do this. Always do this. You see a binomial, stick brackets around it, right? Whether it's the question or anything, just remember, always brackets around it. And what are we going to multiply the 5 over x plus 4 by? X plus 2. Okay, remember, this has to be 1, right? And it is, right? That's a 1, that's a 1. So this gives me 3 times x plus 4 over x plus 2, x plus 4, plus 5 times x plus 2. Okay, so in this case, remember our rules for multiplying, right? You just multiply the numerators together and the denominators. Everybody's good so far? Okay, now we're just going to expand, and so this will be 3x plus 12 over, and this will be 5x plus 10 over, and I'm just going to reorder that, right? It doesn't matter what order you multiply in, so this way they look the same, x plus 2, x plus 4. Okay, so what step are we on? 17 of these 27 steps. Express rational expression. Okay, so we now have equivalent rational expressions, right? So that's the idea. We now have equivalent rational expressions with the same denominator. Okay, so now we add or subtract the numerators. So we got 3x plus 12 plus 5x plus 10 over, and now we can write our common denominator. To extend the page, but I'll write that. Give you a second to write that down. Our binomial denominator is fun. Monomial are boring, right? It's like 2 steps, I'm done. Okay, and we do have our non-permissible values, right? They're like way up there, but. Will it simplify? No. So the 8x plus 22 will factor, right? You can take a 2 out, get 2, 4x plus 11. Why? I'm not going to bother. Why? Well, because I look at this and I say, I could take a 2 out, I'll get 4x plus 11, but I don't see a 4x plus 11 here to cancel it with, so I'm not going to bother. Okay? If I could take something out and get one of these guys in brackets, then I would bother. That's the last step, which is simplify. Okay? Any questions? You got to practice this, right? A bunch. Okay, so we're going to do a bunch more so you get a chance. 4 over 3y plus 1 plus that's what it looks like on paper, right? What are we going to do to it? We're going to say, got a binomial. I'm just going to throw brackets around it, right? Okay, going to do this one the different way, right? The new school way. Okay? So again, if it doesn't make sense, stop me at home. Okay, you need a big fraction bar. What's our lowest common denominator? Do we need a 2 in the lowest common denominator? Yeah, we do, right? Because there's a 2 in one of the denominators, so there has to be a 2. Do we need a 3y plus 1? Yeah, we do. And what else do we need? We also need the y plus 1, right? So we need one of everything, right? If there was a 2 under here, then I wouldn't put the 2 twice, right? So here's how I know I've got the lowest common denominator. If I can cover stuff up and see my denominator, right? If I want to see that first denominator, I cover these 2 up, there's the denominator. Okay, good, because I've got it. If I want to see this, I cover this up, and there's my denominator. That's how I know I've got it, right? If I can cover something up and see my denominator, then it's good. Okay, we got a 4. What do we have to do to the 4 to get it over what it's over now? Or the question is, what's down here that isn't here? Right? So you look at the lowest common denominator and you say, what's down here that isn't part of this? Right? And it's the 2 and the y plus 1. So that's what we're going to multiply by. Okay, now I got the 1. What's down here that isn't under here? 3y plus 1, right? Okay, so take a look at that. I'm just going to pause this while you look. And of course, the restrictions. I just say that because it wasn't very clear. Okay, let's call this 8. Right? Because 4 times 2 is 8. So what's this become up here? What do we get? 8y plus 8 plus 3y plus 1 over.
Since 4 and 2 are both factored out in the top there, could you simplify that? Like, would you still get the same answer, or do you have to multiply?
Oh, good point. Yeah, because we would. No, you can't. Good point, and you can't, because 2 isn't a factor of this. Okay, so you can't cross this 2 off because there's a plus sign, and the 2 would have to be a factor of this and a factor of this. Now, it may happen when we're done that we do end up with even numbers, and then it can go, but right now it can't. Okay? So the bottom just stays the same. Okay, and now we collect like terms, and we get what? 11y plus over and as it turns out, no, we can't get rid of the 2. Okay, this makes sense? I'll pause it, let you write down. Bring your stuff in and rejoin us. Okay, so here it is. What's the first step? Factor the denominators. So, how do you factor 3y plus 18? What's common factor between 3 and 18? 3. Okay, what do we get? So, anytime you factor a binomial, there must be 2 terms in the brackets, right? Because you need to be able to expand this back out and get 3y plus 18. You want to check your factorization? Just check it. Multiply it out. 3y plus 18. Okay, good. Minus y plus 1 over y plus 6. All right, Katie, you're up. What do you want me to do? Oh. Either one, I don't care. What do you want me to do? Okay, since this is a single term, right? I haven't added it together yet, I haven't got anything, then I'm allowed to cancel top and bottom within a single term, right? And we can make life a lot easier. Let's just cross that off, call it 2y. Okay, now we actually have a common denominator, right? The y plus 6 is it. We're just going to write 2y minus y minus 1, but we're going to get there in a second. All right, so we have a single term, and we decided, hey, and you know what? Let's just rewrite it. So 2y over y plus 6, and you know, I forgot my rule, the whole bracket thing. 2y over y plus 6 minus y plus 1 over y plus 6. Okay, that's just cleaning up what we did. So everybody, so we are allowed to, since the 3 is a factor and goes into 6, which is also a factor, right? Because 6y is just a single term, right? It's 2 factors, 6 and y. So we divided the 3 into the 6. Okay, what's our lowest common denominator? Y plus 6. Okay, do I need more than one of them? No, just one, right? Because it handles both. Giving me 2y minus, and don't forget the brackets. This is where they get forgotten and things go really bad. Okay, it's a binomial. It's 2y minus y plus 1. Now remove the brackets. What does it become? 2y minus y minus 1. Okay? The negative distributes through the brackets, right? So it's minus 1 times y, which is minus y, minus 1. Okay? Whenever you see a negative, even if there's a number, if you see a negative in front of the brackets, it's changing the sign of everything in the brackets, right? Like we did when we pulled a negative out, right? We pulled a negative out, we can change the signs around. Over y plus 6, which ends up as what? Y minus 1. Did we do non-permissible values? Y can't be negative 6. Restrictions. Good reminder. Questions? Concerns? Okay. If you didn't do this, you would have put a 3 in the denominator. Your common denominator would have been a 3 times y plus 6. And you would have multiplied this by 3, and you would have ended up having to factor a 3 out and cancel in the end, right? So, you know, you can do it now or you can do it later. It doesn't really matter. It makes it easier the sooner you do it, okay? But it's not a fatal error. If you don't do it now, you can do it in a few steps, okay? Okay, 3 more because you need lots of examples, right? Okay, I'm going to go a little faster. So if I go too fast, slow me down, right? But here we go. So we're going to factor. I'm not going to ask you guys. I'm just going to do it, okay? So this is me. This is what I would do. And this is exactly the work that I would show if I were doing this, right? So stop me if you have any questions or if I go too fast. Okay, I need to factor out of the bottom. 4 is the common factor, and you get 2x plus 1. Okay, if you expand that, you get 8x plus 4. I need to factor properly and cleanly. Okay? So, factor the denominators, then state the restrictions, which now he remembers. Okay, I got to figure out a common denominator. I like to start with numbers. So, big fraction bar, right? Because we're doing this in one step. We're not going to mess around with it. So, I need a 4. I need an x. And I need a 2x plus 1. Okay, I cover up the x. I got my 4 times 2x plus 1. I cover up my 4. I've got my x and 2x plus 1, right? So I do have the lowest common denominator. The 3 needs an x because it's already got a 4 and a 2x plus 1 underneath. The x needs a 4. Okay, it's 3x minus 4x, right? 3x minus 4x is negative 1x. Done? Except for the simplification at the end, which is, hey, got an x here, got an x here. This x is a factor, right? 4 is a factor, x is a factor, 2x plus 1. So it's negative 1 over 4 times 2x plus 1. By the way, 0 is also a non-permissible value, right, because of that x. Oh, I am sucking at restrictions today. Questions? Concerns? Comments?
No, we should just
No?
stop.
2 more. No, you got to see lots. And then 2 word problems. So this you need to see because this gave problems yesterday, right? Okay. Okay, first step, factor. That's a difference of squares there, right? It has to factor. Also, and here's the big clue. When you're doing this kind of stuff, we shouldn't end up with like 3 or 4 separate things in the denominator, right? Unless they're kind of easy things, like a 4, an x, and an x plus 2. Those are fairly easy. But if you ended up with a 3 and an x minus 3 and an x squared minus 9, that's too much stuff in the denominator, right? So there has to be a clue that this would be way too difficult, and I'll be multiplying by way too much stuff, so maybe this thing factors, right? Okay, I got my non-permissible values. Here's my lowest common denominator. I need a 3, and I need an x minus 3. And I see an x plus 3. And I see another x minus 3. Do I need to write it down? No. Because if I cover this up, I have that denominator. And if I cover the 3 up, I have that denominator. Okay. So the 4 needs to be multiplied by the thing you don't have, which is x plus 3. And the 2x needs to be multiplied by the thing you don't have, which is a 3. And just to kind of save a bit of space. X plus 12 factors, but one of the factors, neither of the factors is x plus 3 or x minus 3, so I'm not going to do anything with it. 10x plus 12 factors, but one of the factors isn't a 3, so there's no point in factoring it because I can't cancel it. If this had been 9x plus 12, I would for sure factor out the 3's and then be able to cancel them. Okay, but it's not, so we're done. Okay, questions?
Do you want to write the answer as x plus 3x minus 3, or can it be 3 and then x squared minus 9? Because it's just a difference of squares, so
Like this.
you could expand.
So we're never, in this unit, never expand. Okay? You will never, well, yeah, probably pretty much you will never expand. I can't say that for sure. I'm not sure what the other question is. But I think we're only dealing with binomial denominators. Right? If you're trying to have one with trinomial denominators, you may have to expand stuff out again. But we're keeping it fairly straightforward and simple, right? So for now, the rule is never expand. Factor, never expand. Right? The only thing you can multiply together are monomials. Those are okay to multiply together. But otherwise, we factor, but we never expand. F. At the back, underneath the right flap of the cardboard box. On top of the white ice cream container. Well, actually on top of the gloves, which are on top of the paper, which is on top of the white ice cream.
I get it.
Here, wait, I'll take a picture of it. I can put the picture up here and point it to.
Not that stupid.
It's like telling people it's in the long skinny drawer at the back and they're pulling drawers out, but they don't get the right one. X squared plus 4 is a sum of squares. Oh, sorry, we're not even factoring numerators, right? So we're just factoring denominators. Okay, x squared plus 4. This is a difference of squares, right? They're both squares. There's a minus sign. They have square roots, so it's 2 plus x, 2 minus x. I hate when it runs out of ink. I think it's back now. Just had to reload. Reload. Okay, that's a binomial. So x cannot be 2 or negative 2, right? Because those will give me zeros, that's restrictions. What's my LCD? Okay, well, I need a 2 plus x, right? I need a 2 minus x. Do I need another 2 minus x? No. What do I do to the x squared plus 4? Nothing, it's already over it, right? what do I do to the minus x? I'm going to throw that in brackets. 2 plus x, right? So you look down here, you say it's over 2 minus x, so I need a 2 plus x there. Okay? Now let's drag this down. So we get x squared plus 4. Okay? What? Expand. Minus 2x minus x squared, right? This is one of those. Here, slide that up a bit. Okay, x squared minus x squared, gone, giving me 4 minus 2x. Okay. Now, does the numerator factor? Okay, what will it factor to? So what are we going to do now? See, we saved the best for last, right? So in the end, that's the simplifier, right? Like step 7 or 8 or 26 in that list. Is in the end, now you get to look and you say, I have 4 minus 2x. It is factor, yeah, it obviously factors because they're even. It's 2 bracket 2 minus x. Hey, I've got one of those on the bottom. So I want to do the factorization, cross those off. But keep in mind, your non-permissible values are still plus or minus 2. Right? Even though the only obvious one left is negative 2, right? It can't be negative 2, but it also can't be positive 2. Okay? Questions? Concerns? Other than this is going on forever. 2 more of these are word problems. Okay? So we'll call this number 3. And this is the setup. We're not going to solve these. So in these, we're going to take words. We're going to create an expression involving them, right? A rational expression. Okay, and we're going to simplify it, but we can't solve it because I don't think it solves. Jimmy swam 500 meters upstream. To his cousin's cabin. Bless you. I think we're pretty good at that as a class, you know. He then swam 500 meters downstream back to his own cabin. To his own cabin. The speed of the river. What? The speed of the river was 100 meters per minute. Okay. So if he got it to go downstream, if he just floated there, how long would it take him to get back to his cabin? 5 minutes, right? So he just didn't swim, he just sat there treading water or whatever. The stream would move him 100 meters per minute. 5 minutes, he'd be back at his cabin. Assuming that Jimmy swam at a constant speed.
So if the river's going that fast, how did he get all the way up? Is he just a badass?
Well, he swims faster than 100 meters per minute. Well, how fast does Michael Phelps, you know, how long is 100 meters in the Olympics? Anybody know? I don't know. So many. I mean, it's like 20 or 30 seconds, I think they do it. I think. Okay. Assuming that, or Jimmy's badass. Assuming that Jimmy swam at a constant speed. Yeah, when I saw the number, I asked myself, is that reasonable? constant speed, write a single rational expression that represents the total time of his swim. The total time of his swim. Okay, so we're not solving this. What will happen is tomorrow we'll give you the total time and then ask you how fast he swam. Okay, but today we can't solve this. We can just set up an expression, right, that represents the total time. Okay, in word problems, you need to communicate to basically me, because I'm the one that's going to be marking it, but to somebody else too, right? If somebody's looking at your solution, you need to be able to communicate to them so if they're looking at it, they can, you know, they're not asking, what the heck is this, right? They'll be able to look at it and say, oh, okay, I see you used X, and X stands for this. And so we would say, let X be the speed at which Jimmy swims. Right, so he swims at a constant speed. So if he's going upstream, he's fighting the current, right? If he's going downstream, he's swimming with the current. But he's always going to swim the same speed, regardless if he's going upstream or downstream. Okay, this also applies to paddlers paddling. It applies to planes flying in the air, right? Against the wind or with the wind. You fly back east. I just say back east because I'm from there. If you fly back east, then you are fighting the wind. No, you've got the wind at your tail, so you go faster. If you're flying from east to west, then you're heading into the wind, and you know, either the plane has to fly at a faster speed to maintain its ground speed, or it's going to take longer, right? Which is why it takes longer to fly from Toronto to Calgary than it does from Calgary to Toronto, right? Not by a whole bunch, but you've got to fight the wind. Not time zones don't count. If you start a stopwatch, those are the time zones. You get there 2 hours. It takes less time to fly back then, because hey, I got here in 2 hours. I left at noon, I'm here at 2. Whereas when I left here at noon, I got there at 6. It took 6 hours to go out there and 4 hours and 2 hours to come back. How it works, it's 4 hours pretty much either way. Okay, let X be the speed at which Jimmy swims. So when Jimmy is swimming upstream to his cousin's cabin, then how fast is he going? He's going X, but the current's going 100 against him, so his speed is what? So I'm swimming at X, current's going that way at 100 meters per minute. How fast do I end up going? X minus 100, right? Now, time, right? You must know this. Distance is equal to speed times times. We want an expression for time, so time is distance divided by speed. So he's going 500 meters, and he's got X minus 100 is his speed, right? Going upstream, he's fighting the current. So his speed upstream is X minus 100. And the time it takes is 500 divided by X minus 100, right? Distance 500 over speed. Total time. Well, when he comes back, he's swimming 500, but he's going downstream, so what's his speed? X plus 100, right? So that's our expression for the total amount of time that Jimmy is spending. Now, if we wanted to solve this, we would need to know what the total amount of time was, and we could solve for X. That's tomorrow. What we're doing today is just simplifying this expression, right? So, to simplify this expression, we need to get a common denominator, which is what? Yep. Sure. Okay, so it's X minus 100, X plus 100, right? This 500 here, what are we going to do with it? Multiply it by X plus 100, right? Because it's already got that. This 500 here, what are we going to do with it? x minus 100, right? The thing that it's missing. It's got the x plus 100, it needs the x minus 100. Okay, so we get 500x plus, what's that? 5 followed by 4 zeros, plus 500x minus 5 followed by 4 zeros. And collecting like terms. Okay, oh, and restriction, of course. His speed can't be 100 meters plus or minus 100. So that's our simplified expression, right? Which then if we had to solve, we would do various solving techniques too. Okay, questions? One more. Sorry. This is more like pure 30 than I thought it was, as opposed to applied 30. There's just a lot of stuff to cover. Jill invested $1,000 in shares of A stock on Monday. Comma. And another $1,000 in shares of the same stock on Tuesday. The price of the stock was 25 cents lower. So on Tuesday, the price of the stock so $0.25 lower than on Monday. So when did she buy more shares, Monday or Tuesday? Tuesday, right? Because it was cheaper. So you should get more shares. Write a single rational expression just going to abbreviate that, RE, that represents the difference in the number of shares in the number of shares she bought on the 2 days. Okay, so we need a variable. Why? We usually use x, but I could see s maybe, or p. So let's let x be the price she paid on Monday. Let x be the, I know what she's asking, the price paid on Monday. So how many shares, if she paid $1 a share, how many shares did she get? 1,000. She paid $100 a share, how many shares did she get? 10. She paid $1,000 a share, how many shares did she get?
1.
She paid X dollars a share, how many shares did she get?
X.
No. She paid $1 a share, how many shares did she get? 1,000. She paid $2 a share, how many shares did she get? How'd you get that? From 1,002. Okay? She paid X dollars a share. How many shares did she get? She paid $10 a share. How many shares? What operation did you do to get that? So what do I do with the 1,000 and the X? to get the number of shares. Divide. That's how many shares she bought on Monday, right? It was $2 a share, 1,000 over 2 is 500. Did she get more shares on Monday or Tuesday? Tuesday. So let's subtract that from the number of shares on Tuesday, which is what?
X minus 0.25?
X minus 0.25. Exactly. Okay. Now, if we were going to solve this, that would be equal to something and then we would solve, right? But we're not. We're just going to get a single rational expression. So we're going to combine these guys, right? No solution here, just a simplification. So we need an x minus 0.25 and we need an x, right? They're different. This 1,000 here is going to get multiplied by x, and this 1,000 here is going to get multiplied by x minus 0.25. Okay, and then we're going to simplify. Let's see if I can just do that up here. Uh, 0.25, 1, 2, 3, plus 250. Okay, and there's the answer.
So she got 1,250 shares on Tuesday.
Alrighty.
So get it.
If we don't know how much she paid, we can't solve this. Okay, we can come up with a simplified expression, right? And all we're going to get from this is the difference in the number of shares, right? Like if she paid $10 per share, then you take 10 times this, 250 divided by that. That will tell you the difference in the number of shares. Okay, and this will tell you how many on Tuesday, how many on Monday, right? I mean, if I told you what the stock price was, you just work out, you just say, well, you bought this many, and the difference is this, right? But we're just trying to get a rational expression. Okay, look, done. Huzzah, right?